Hello, my name is Jay Carpenter of the Funword Forum, and today is Wednesday, February the 29th, 2012. It's approximately 4 p.m. Eastern Time, and today on the Funword Forum, our guest is Mr. Martin Geddes of Martin Geddes Consulting, and we are talking about the Sender Pays Data mobile broadband model, and also I'm sure we'll be touching upon the announcement by AT&T this week. So had a couple people just join. Anybody like to announce themselves?
Hi, Jay. It's David.
Hi, David. Welcome.
Thank you.
Anybody else like to announce themselves? And by the way, on the Funword Forum, you don't have to announce yourself. It's we welcome people to attend anonymously. Hello, who just joined?
Hey, Jay. It's John Evans, the 800 response.
Hi, John. Welcome.
Thank you. I think David may be joining as well.
David is on as well. Martin Geddes is on. And we have someone else who hasn't announced themselves, which is fine. Hello, welcome.
Good afternoon. This is Warren Bench.
Hi, Warren. How are you?
I'm well. Yourself?
Very well. Welcome. Appreciate you attending today.
Excuse me?
I appreciate you attending today.
Oh, well, I appreciate the invitation.
All right. Hello, welcome. Would you like to announce yourself?
Robert Schaefer.
Hi, Robert. Welcome. Appreciate you attending today. We'll give it about one more minute, and then we'll get started. Hello, welcome.
Tom.
Hello, Tom. Welcome.
Thanks, Jay.
Hello, welcome.
Jay, it's me again, figuring out how to actually use a phone, I guess.
You know, John, in your line of work, that's a good instrument to know how to use.
Yeah. They need a model that you can operate with boxing gloves, apparently.
It's amazing to me. I've been on so many, telecom industry conference calls, and the number of technical snafus is amazing. So, anyway, I think we'll go ahead and get started. We'll probably have some other folks that trickle in, but I am delighted to welcome our special guest today, Martin Geddes of Martin Geddes Consulting. Martin was the strategy director for BT Design, and I consider him one of the key industry visionaries and thought leaders. And I've followed Martin's writing and work and thought process for years, and had the opportunity to meet Martin last year at the ECOM 2011, where we got to talk a bit. And Martin, for those that might not be familiar with Martin, was one of the first to really talk about the Sender Pays Data business model. And today, Andy Abramson noted that in a tweet and actually harkened back to, I guess, a dinner that Martin had with Andy, where Martin introduced Andy to the notion of Sender Pays Data. So for those of you that have not yet taken a look at Martin's paper, which is on his website, I highly recommend you do so, called Connect, Interact, and Transact. I think it's a very forward-looking piece and touches upon some some key elements that are in place and underway right now. So, Martin, I'll go ahead and turn it over to you. But before I turn it over, is there anything that anyone would like to say, any particular topics you'd like to cover today before we get started? All right. Well, this is pretty much an open forum. We'll chat about whatever topics come up. But Martin, I'll go ahead and turn it over to you. So take it away.
Okay. Well, thank you, Jay, and I very much appreciate you inviting me this evening. I'm here in London at the moment. So I'd kick off with giving a little introduction to myself so that people know my background and my interests. So I used to work in the IT industry in the 90s. Used to work at companies like Oracle building big database systems. And back in 2001, a friend of mine invited me to come and join Sprint, and I joined SprintPCS.com, a business unit. And my job was to be on a skunkworks building a open web API platform. And we even had developer conferences in Las Vegas at Caesars Palace and MGM, 600 people and $2 million budgets. And we're going to launch this platform. And what happened was that the white blood cells of a conservative Midwestern telco came and surrounded it, and the project was canned, the VP was fired, and the whole business unit was dissolved, which left I had a little time on my hands, and the devil suitably found work for me. So I started blogging about the future of the industry and telecoms industry. So I found telecoms to be its technology, but not as we know it, and particularly for someone who came from an IT background. And it came with a completely different lexicon, different assumptions, and very different technical building blocks. So that snowballed into a whole new career. I co-founded, I think you might have heard of, called Telco 2.0, which is a conference and research consulting business. Then I joined British Telecom. I was the strategy director for network and IT division, and then moved on to found my own consulting company called Martin Geddes Consulting. And my special interest is in around the future of voice and messaging. I do work on a number of general areas. And if you're interested in following the things I do, then if you look at futureofcomms.com, you'll find there's a little sign up for a newsletter which we send out once a month. Or you can go to martingeddes.com and sign up for the newsletter there. Good. So a couple of things I wanted to talk about this evening. So I'll lay out a few different idea areas and maybe start off with a little bit about what I see going on. I'd really encourage, if anyone wants any questions of clarity as I go through this, is please try and stop me. So if there's something I'm telling you and you don't understand it, then I'd rather you stop me and ask for an explanation. And then maybe towards the end we can then open up for debate. So hope that works for everybody. So there's two things going on in the industry at the moment, and they're all parts of a bigger phenomenon, which is the what I call the peak telephony. Is the rise over 100+ years of telephony has kind of reached its peak, and as a main way of delivering voice, and now we're seeing voice become many different applications. There's two things to highlight. So one was this last week. You saw AT&T, may have seen AT&T announce a form of sender party pays data, or an intention to launch sender party pays data attached to applications on the AT&T platform. So what AT&T are doing is creating this platform, and they're trying to attract developers to their platform. And there's a second half to this problem, which is how do you attract customers? So AT&T already has its own customer base, but there's a second trend, which is operators increasingly are offering what are known as over-the-top services of their own. So like T-Mobile has Bobsleigh in North America. So if you're not a T-Mobile customer, you can still download the T-Mobile Bobsleigh application. Telefonica has Jar Jar and a number of other ones in the pipeline. NTT has the fixed landline provider in the US has a service called 050 Plus, which is aimed at attacking the non-NTT mobile operators, so SoftBank, KDDI. So increasingly there's sort of this form of mutually assured destruction where telcos are busy trying to nick each other's customers, either directly, so move to me and become an AT&T customer, or just grab the experience off them. So you've got this platform that's trying to, on one side, attract developers, and the other side, attract customers, or users at least, because increasingly the user is the product. So that's what's going on in the industry. And then there's three, I think, really critical or interesting things about sender pays data that I've learnt over the years. I want to go through these. So the three things, the first one is called the packaging problem. So it's all about postage and packaging. And the postage is about who pays for the transport, but there's a bit that goes with it, which is the packaging problem. We'll talk about that. Second one is about quantity versus quality. So in existing toll-free, it's all about minutes, which is about quantity. But on broadband, we have a number of richer possibilities. Let's talk about some of the things that may be not obvious there. And then the third thing is what comes out of that Connect, Interact, Transact paper that I wrote. And it's zooming out a bit and looking at what's the real business problem we're trying to solve here, and for whom, and who's really going to pay, and pay for what. And the Connect, Interact, Transact model is a way of trying to capture the essence of that. So I guess these three areas and lay out some ideas that maybe might be new or different to what you've heard before. And all three relate to the platform that's trying to join together developers or merchants to customers or users. So the packaging problem I see as being about, if you think of a physical parcel in front of you, then it's got a jiffy bag or bubble wrap around it or something. And the purpose of that wrapper is twofold. So one of which is to keep the stuff that's meant to be inside stay on the inside, and the other part is to keep things that are meant to be on the outside stay on the outside, not get it inside the package. And we have a comparable problem with sender party pays data. So it's how do we know which packets or which part of the data flow is supposed to be accounted for by whom and how. So give you an example of the kind of the issue around the packaging problem. Let's say you've got a Facebook page with a YouTube video embedded into it. Then the packaging problem is in the network. It becomes very hard to distinguish which YouTube videos are part of a Facebook experience, which maybe is part of a zero-rated Facebook plan or something, versus just general YouTube traffic. So there's also a problem of maybe one application is zero-rated, as sender party pays. How can you avoid other applications trying to tunnel their traffic through that? So I think there's a question mark about how to solve that. Now, I believe you had Boxstop present on a previous call, and they've got one particular way of doing that, which is putting software in the client and the home gateway on the set-top box, and identify it at source. But I think that there's a huge amount of work required in terms of how we build endpoints that are capable of managing this packaging problem. And I think the packaging problem sheds some light on developments like this week with AT&T. So you can imagine this spectrum, excuse the pun, of at one extreme you've got something that's totally perfectly packaged. So an example of that would be SMS as a package not just of a data transport and an application service, but it's the packaging of how to pay for it, how it will get supported, identity and provisioning, the SIM cards, the whole cash collection process around. You can go to all kinds of outlets and pay for your prepaid data and prepaid SMS. There's a governance mechanism that comes with it. So if someone sends you an abusive SMS, then you know who to call to deal with it. It's this beautiful package all comes together. the other extreme, you've got completely unpackaged applications and services. So a standard broadband ISP doesn't have any relationship between, any commercial relationship between the website or service you're trying to reach and the transport provider. And what we're trying to do is find when it's appropriate to go for a packaged model and when it's appropriate to go for a very unpackaged model. I think a lot of the network neutrality debates are assuming that always this unpackaged model is great and we should always try and separate transport from the services. But I don't buy it at many, many levels. We'll come back to that a little bit in a moment. But the key one is that we managed to reach the last 3 billion people who we managed to reach on the planet with connectivity all did it with telephony and SMS, not with internet. And so there's something very powerful about these packaged experiences. And I think there's a strong argument that they help bring affordable, usable services to the masses. And that makes me quite optimistic about the future for single party pays models of various kinds. So that's the first thought, is the packaging problem, is how to keep stuff on the inside that's supposed to be inside, keep stuff that's on the outside that's supposed to be on the outside, and when to package things up and when to have them loose, as it were. So the second part of the puzzle, I think, is about quality and quantity. Now, to tell you something I think is going to melt in your mind a little bit, which is quite challenging, which is everything we do today on broadband networks is locked into what you might think of as the bandwidth metaphor. So the classic with centre-party pays data is charge for the volume being sent. It's all about quantity. And if you think about even how things like voice over IP are often made to work on packet networks, it's about recreating the effects of circuits with SIP or IMS or various technologies, so that we allocate a path of a fixed quantity or bandwidth, so that the packets are provisioned to flow without too much jitter or whatever. And this is running up against a fundamental problem, which is it's not true. Is networks are not pipes, and networks actually don't even have bandwidth. Point-to-point links have bandwidth, but networks are complex distributed systems that involve statistically multiplexed data, being multiplexed and demultiplexed to queues every stage. And unlike, say, a physical pipe with gas or water in it, you can't compose the links in networks and get the same quality out at the end. So again, okay, is with a physical pipe, it's got water flowing through it. You can put two pipes together, and the same water flows all the way through. Networks do not work this way, and rather than being like pipes, in some ways they're more like, again, excuse the pun, they're more like bells. Is if you clang one on the side, like you send SYN and NAC packets TCP, they resonate, and sometimes these resonances inside the network are in phase, and sometimes they're out of phase, and we get all kinds of interesting effects due to the phasing going on in the network. So that networks are not pipes. They're more like large distributed supercomputers, and they have a property that was discovered in supercomputing but has not really yet been applied properly to networks, which is they have 2 degrees of freedom. The systems are 2 degrees of freedom, which are loss and delay. So loss and delay together make up quality. Right? So, to give you an example, if I'm transmitting data over a satellite link, then I might be getting 10 megabits per second, which is quite a lot of quantity, but the latency of going up to some geostationary orbit and back gives me very high delay. So the quality of what I'm getting is very low. And what's really interesting is as a system of 2 degrees of freedom, loss and delay, these two can be traded. So every sender party pays data model today has been anchored in the idea of bandwidth and charging for the quantities of data that are transmitted. This does not match the physical reality of the network, which is it is a statistically multiplex system where the fundamental resource is not bandwidth but contention. And what we need to do is think about how to price the true fundamental resource, which is contention, which is composed of loss and delay, so that quality aspect of it. And so, give an example of that could be you could have a form of sender party pays data which would be pre-caching movies down to people overnight, and it could be a scavenger class of traffic that is delivering a great deal of quantity but not using up any of the available quality, so it runs at a very low priority, and that opens up a whole world of new pricing opportunities for sender party pays data that both at the high quality end and also the scavenger traffic at the very low quality end. So that's the second phenomenon that is worth noting is to make sender party pays data, you need to look at quantity and quality in conjunction, not just quantity. Then the third part of the puzzle that I see, which is what problem are we really trying to solve here? What I observed in my work at Sprint, building an open web platform, is that the phone companies have kind of got embarrassed about being a phone company, as if it's some kind of dreadful social disease, and they got totally fixated on data and video, and have forgotten what the problem was they're trying to solve with telephony in the first place. So I spent a couple of years going around and reading all kinds of research and slowly putting together a model of what is the thing we're trying to do here. And what I concluded is that there's a big opportunity for operators to build APIs that solve problems of customer contact, particularly through voice and messaging. And then underneath this is where the sender party pays data comes in. So give you an example. So today, if I'm a call center, then it's hard for me to take inbound Skype calls, and there's no way of me contracting with the various carriers who are delivering the call to make sure it's of the quality necessary to serve my customer. So this is an example of where it might be a form of sender party pays data, but rather than it might be elements of quantity and quality that are being delivered here. But I think that the problem is much more rich than just being able to deliver voice bits at some constant bit rate. What I think, if you think about what FreePhone originally did, what problem it was solving, which was it was delivering, it was an API for customer leads. Effectively, it was the first thing you want to do with an 800 number was put it up for a sales inbound sales line. So really, it wasn't a way of giving free minutes. It was a way of giving an API for customers, and give me next customer. And I think we can take that thinking and expand it a great deal. So when you get a customer delivered to you, then who is this person? Well, what more have you got apart from a phone number? What else can you tell me about them? Help me interact with this customer in an appropriate way. Yeah, so habla español. Well, why use up the first level of the IVR in working out which language you speak? Because if the customer's only got a tolerance for 2 or 3 levels of IVR, you've already wasted a third or a half of your automation possibility. If I want to leave a voice message for this customer, then why do I have to pay an agent to listen to their voicemail greeting and then manually record it? And it's like, why isn't there an API to leave a voice message? So new ways of interacting with customers. And on top of that is, well, if the customer's called into me and they want to say, pay a bill, they want to buy some tickets from Ticketmaster, and Ticketmaster is taking inbound calls, then where's the equivalent of PayPal for voice? It lets the user complete the transaction, charge it either to a telecom bill or to charge it to some other payment instrument, but facilitated by the telco. So there's all kinds of opportunities to build value-added stuff on top of the basic connectivity. And at some level, if the money's in the interaction stuff or the transaction stuff, then the sender party pays data doesn't become moot, but it becomes not necessarily paid for explicitly. It gets paid for as part of a bigger bundle of value exchange between the operator and the merchant. But I think what's critical is to note that there's a whole bunch of APIs you can build to make customer interaction efficient, effective, and secure, and those can be consumed at industrial scale by ERP and CRM systems. And that's where I see the future going. Actually, is one of the places I think that the whole sender party pays data model might start with is taking the business we've already got and enriching it, and allowing a greater range of contact mechanisms. So if the users are using Facebook, Viber, over-the-top telco voice, all kinds of stuff, let them reach the enterprise and have their voice understood, and then build on top of that layers of value-added services. So those are the three core elements I see of the problem. So the packaging issue, quantity and quality, and then connect, interact, transact. Which layer is the money really at, and therefore who's really paying for any sender party pays data. So that's me talking for 20 minutes. I'd like to, Jay, over to you, and let's have some questions.
Martin, I hadn't considered the packaging component. I think that's a really interesting element of this, and I can see where that, under the current architecture, that would be a challenge to tease out, okay, who is the sending party that's going to pay for this?
Right. So there are actually some links between these different ideas. So as long as you're stuck in the bandwidth metaphor, then you've got to somehow unpick which flow is this, or to whom am I going to allocate the chargeability of this packet? And you've got a whole bunch of very expensive DPI stuff going on to try to reverse engineer what is it this thing's supposed to be. So doing it in the network for the bandwidth metaphor, I think, is a futile activity ultimately, and the only way of doing it is at the endpoints. Although then you're opening yourself up to a whole bunch of potential security issues, but I think that's solvable. But if you move to a contention, sorry, your question?
No, I'm sorry. Go ahead.
So if you aren't doing bandwidth management, but you're doing contention management, then that's something that really doesn't care at all what the is in the packets, as long as you have some way of if you want to receive the higher qualities here, which is different from quality of service, right? This is something that's really hard to get your head around. So quality of service and prioritization is part of the bandwidth metaphor. Right? It's a way of allocating more of the bandwidth to particular applications, but it comes at a high cost, really, really high cost. So every time you prioritize one kind of traffic on your network, what you're doing is allocating more of the available bandwidth resource, but it does this in a way that shrinks the overall value carrying capacity of the network, and so the real cost of prioritization is not carried by the traffic that's prioritized, but it's carried by all the other stuff around, and it doesn't. There isn't like a conservation law here, and the more time sensitive the traffic is that you're trying to prioritize, the more that shrinkage effect. So the more fallow network capacity you need to have to keep your traffic within the quality bounds of latency and jitter and packet loss that you want to achieve. And
so can I ask you a question just to get clear on this, because I think your analogy between the pipes and the bells is really key. Because if I understand you correctly, under the pipe model, which a lot of us are used to thinking in that framework, you know, if I want a higher quality, then I'm saying, hey, give me higher pipe diameter, or give me 2 or 3 pipes to give me better quality. And you're saying that doesn't hold. But under the Bell model,
it comes at a very high cost. But so networks are more like bells in that they have complex resonance effects and phasing interaction issues between all different flows. They, at a very deep fundamental level, are not pipes. The moment you put a queue in the middle, you've got a certificate of complex resource that does not behave the way that pipes do. So, for example, with a pipe with water in it, you can't let the water leak out. Whereas with a packet network, you can choose. The default on packet networks always is to try and deliver the packets, and so we try and put longer queues in there and not throw them away. But actually, often the right thing to do is to throw them away really early, to send the signal back to the application to slow down. So what really matters in terms of delivering the quality of experience to the user is the quality characteristics that the flows experience over the network, which is their loss and delay, and by working on understanding how loss and delay can be traded between flows, and with a contention management model, you can effectively hold the size of the pi constant while dividing out the fundamental resource of contention, and that I believe is the missing key to making sender party pays data work, because otherwise, the economics of it are every time if you try to do any kind of prioritization, or even if you think of the scavenger traffic, if you try and build scavenger traffic class, because you're built using control loops like TCP across your network, basic control theory tells you that there's a speed of light plus all the queues in the middle. So if there's any contention in the network further down and loss and delay that's being experienced, you can't learn about it until half a second later. And it's too late. You've really kind of got in the way of some other traffic in that process. So the traffic ends up contending with itself. It's an odd phenomenon. And so it's just really, really hard to get your head around, because everybody, the whole industry is locked into the bandwidth metaphor. And all the work we do today on packet networks, what actually happens is, talk about that with resonant effects, is as you push the network, as you start loading it up, it behaves linearly at first, and it fits with your intuition of what the bandwidth metaphor would do. As you get towards saturation, then what happens is at the point of saturation, you push the network as a system into its least deterministic point. And TCP does this. TCP deliberately loads the network to 100%, exactly 100%, which is the least deterministic point, which generates the most arbitrary outcomes to the user in terms of the quality experienced. That's really important, because arbitrary is bad, random is good, but arbitrary can just do anything, and it can work perfectly for a few moments and then just totally stop as all the packets get in phase with each other in the wrong way, and buffer bloat's an example of that.
So, this is a new concept to me, and I get the arbitrary versus random descriptor, but which is really wild. But to get back to the Bell analogy, it sounds to me like under the bandwidth, Bell analogy, you've got two choices. You've either got to make your bell louder than the other bells to increase the quality, or you've got to quiet down the surrounding bells. Otherwise, everybody just... Would that be accurate?
It's more like, imagine with one big bell that resonates. yeah, and various people are tapping on it, and the other side people have got microphones, and you're trying to get your signal through. I mean, obviously this metaphor is going to break down at some level because the bell is analog, and there is the wild irony, of course, of bells in packet networks. It's these phasing effects of the packets, because in real networks, packets don't arrive with some Poisson distribution. They come pulsed by various applications, and what matters to if you want to do quality assured sender party pays data, then either you have to vastly over-provision your network to make sure it never gets in saturation, which makes it expensive, or you lose control of the quality of experience as it gets to that point of saturation and it behaves arbitrarily. And I'm saying there's actually another choice, which is to stop using the bandwidth metaphor entirely and realize that there is a fundamentally different way of managing your network, which is to do contention management. But that requires a whole different set of techniques and approaches that today are basically just, they've escaped from the research lab, but they're really, really new. But without them, sender party pays data has a great deal of limitation. It doesn't work well on broadband, where you have many different quantities and qualities of traffic being multiplexed together.
Let me let's take a hypothetical. Right now, we've got the network ecosystems environment of I would say network-centric and endpoint-centric architecture. Let's assume that we had a totally peer-to-peer endpoint-centric architecture.
Yep.
Would that satisfy some of the issues that you're talking about?
No is the answer. Let me explain why. So if you think of, you've got this networked resource, which all these devices at the edge are trying to communicate with each other across. And then at various points in the network, as we architect it today, where every point is a queue, multiplex up and demultiplex. And every time you either throw away a packet or put it in a queue behind some other packet, that you are causing some impairment to quality of that flow. Now, if protocols like TCP, all they do is detect loss. If I lose if there's a loss, then back off. If there's not loss, keep doubling up, whatever it is. They have no way of really dealing with delay. And there's some minor variants on TCP, like I don't know how to pronounce it, UTP or microCP, the BitTorrent uses, that try to adapt for delay. But the basic problem is a control theory one, which is if all this delay is occurring in the middle of the network, the signal about what's happening there can't be passed back to the applications at the edge to say faster, slower, and to coordinate any faster than A, the speed of light, plus B, all the time it takes for those packets themselves to go through queues. So the edge is, you've always got the feedback mechanisms going on here between all the different parties communicating that are saying faster, slower, trying to manage the utilization of the resource between them. All are working on greedy algorithms like TCP, all of which try to drive the network to 100% of its load, which is the point at which it behaves arbitrarily. And so you fundamentally can't solve the problem using a pure edge architecture if you really care about quality of experience outcomes. And you see this, you actually experience this in real life. So there's a problem with buffer bloat. If you haven't come across it, then it's easy to Google. And Jim Geddes has been doing a lot of research into this. So you get this collapse effect on packet networks. And the reason you get the collapse effect is you get these resonances that get in the right-wrong phase. And because we put too many long queues into networks, you get these huge, suddenly like stop, like you get 30-second ping times. and and the other, I lost my other train of thought. The other effect that when you can't coordinate from the edge is you get buffer bloat, and I've forgotten my other train of thought. We'll just come back to it. The quality. You can't assure the quality of experience either. So if you're trying to do sender party pays data, then of traffic that's been multiplexed together, then today the only way you can assure the quality of that traffic is to completely separate it. So make bandwidth reservation, even if you're not using any of that capacity. Whereas the alternative is to do contention management, which lets you do statistically assured flows. But that is a new paradigm for managing packet networks, which to me is until you have that, you haven't got the prerequisites in place to do many of the more interesting sender party pays data models.
What do you think it would take to usher in that new architecture?
Well, it'd be no surprise to you that I'm an investor and partner with one of the companies that's doing it, and it's as with all good new ideas, they're fiercely resisted by the incumbent ecosystem. Because at the moment we over-provision our networks by a factor of maybe 2 to 5 compared to the theoretical capacity we actually need to deliver the same outcome, to buffer all these temporal phasing effects of packet flows. And so it's, at some level it's okay to carry on within the bandwidth metaphor as long as you realise it's going to cost you up to 10 times as much as you need to carry the traffic. And if you want to do really timing sensitive traffic, like say sender party pays data for femtocells being backhauled over domestic broadband, then you need to put fibre in, because you just can't do it over copper. Just accept that there is a limit to what you can do within building control loops that go across the whole network to try and manage the contention that way. So what's going to cause it is the bandwidth metaphor is fighting physics, and it's fighting mathematics, and ultimately it has to give. And it's just a question of which parts crack and who needs to shift first. But it's going to be one almighty transition. It'll take decades.
And just so I understand, when you say contention, you're saying that it sounds like you've got some sort of like traffic cop that's over the network.
Yeah, a little bit. So any point of ingress to a network, you have a single point of control at which you have the opportunity to pre-contend the traffic so that it doesn't need to go through any queues downstream; it just goes. But you've thrown away traffic at that point as well. If there's not enough quality resource, loss and delay left to allocate, you just have to throw it away. It is like a traffic cop, and of course you still need to have a policy engine on top of it to say who gets what quality. There's no free lunch here. But the fundamental resource is not bandwidth; it is contention. So if I build a scavenger class traffic which goes that doesn't use these control loops, but just is in packets that are injected at any moment where nothing else is waiting, then that lets me build a zero cost or zero marginal cost scavenger class, which you can't do today.
So if you had an overall an architecture that where you could effectively implement certain governance and policy rules, that would go a long way towards ushering in this contention management.
Yes. It doesn't mean that you can't make any progress on sender party pays data without it, but to me it is the missing vital enabler, because it solves a lot of packaging problem issues. and it's a bit too much on this call to go into the details of how and why. B aligns your cost and revenue in that your cost is driven by contention. So if you're charging by quantity, not quality, which contention is about the quality, then you've chosen an orthogonal axis. It's like, well, that doesn't work. Or if you try and manage things by jitter, jitter is a second order effect. It's the average of the variance and or standard deviation, whatever. And trying to control your network through second order effects rather than the primary first order levers of loss and delay, you're kind of driving from the back seat. You can make progress, but you have to realize there are some fundamental mathematical limits to how much progress you can make. And there's still a whole bunch of really interesting things you can do. So I think there's a grand opportunity to rethink and extend the 800 number model, because on IP, if you stop worrying about all the stuff about how to deliver the basic voice service, but think about what is it the enterprise needs. Is they want APIs for relating to customers. Help me relate and interact with this customer well. So if this customer is roaming, if this customer is in Hawaii, and they're normally on the East Coast, they've got a 212 number, whatever it is, then maybe it's not a good call to make, a good time to make the outbound call when it's 3 a.m. in Hawaii. It's basic APIs to help people rendezvous and synchronize their interactions and exchange data securely and be able to follow up the call, or maybe an API. If I call the call center, then they can still proxy an email back to me via AT&T. Whatever it is, your imagination is the limit as to all the things you can build as value-added services off of a basic 800 number call, but it does require an IP infrastructure to signal it.
I completely agree, and I think the more you think about it, and actually, if there were some, prototype platforms, I think people would get really, really excited about this once they could see, how this can manifest itself in real life. But just to go back to an example that's been articulated in the past, it used to be that the postal system ran on the receiver pays model. So when you received a letter in the mail, you would go to your mailbox and you would have to pay to basically get those letters out. And then somebody came along and said, no, wait, we want to change this around to a sender pays. And by the way, the receiver pays model was wasn't very appealing to people. But then when it was reversed around to sender pays, so that the sender of the letter pays the postage, all of a sudden mail exploded. So there are, in some ways, our current peering and transit model works at a network interconnect level rather than a flow level, and some flows, the A party, to the extent there is an A party and a B party in a flow, a bidirectional flow, one party has a greater incentive to pay for it than the other party, and we really haven't worked out how to recapture that, and nobody's done the penny black stamp for data yet. So I think there's a whole world of, particularly in emerging markets, of the opportunity to do center party pays data and packaging, and there are some extra complexities on mobile, by the way. So contention management doesn't solve all the world's problems. If you're going on an uplink on a mobile handset to a base station, that's a distributed control problem that has a different set of contention properties. But I think there's a great opportunity in emerging markets for sender party pays models, and in sort of a whole world that's below the iPhone and the Apple ecosystem, and even below the Android one. That
if I was 20 years younger, that's where I'd go and put my energy and effort probably.
I'd like to shift gears just a little bit and talk about addressing, because particularly in the legacy toll-free telephone number ecosystem, and particularly with the conversation that's underway and the initiative that's underway to, some people don't like this term, but sunset the PSTN. There's a whole addressing issue that opens up around this, toll-free mobile broadband or toll-free broadband or, sender pays data. And then on top of that, there's there's what we saw today or this week with AT&T announcing this, sender pays data API that they're talking about rolling out next year. And then we're also seeing Skype announcing, hey, we'll pay for your connectivity, what is it, on Wi-Fi or whatever. So, there seems to be, we seem to be on the brink of a, let's say, kind of a free-for-all for sender pays data.
The question to me is who are going to be the middlemen, who are the platforms that join the either the merchant, basically join the merchants to the customers. Yes, I think Amazon Kindle is to me currently the most fascinating sender pays type model. That's and
just to finish the point for consideration in this particular realm of the folks that'll probably be, most of the folks that'll be listening to this call, it's far from a given that the legacy toll-free telephone number of 1-800 blah 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 is going to be in the middle of that.
Yeah, I would totally agree. I think at the moment it's actually a deep risk of being displaced because it isn't evolving for the mobile social cloud world that we're moving to, and other APIs of delivering me a customer and help me relate to this customer and interact with them securely, efficiently, effectively, will displace it unless it evolves. Now, of course, the original 800 number was introduced. What year? It was pre-divestiture, wasn't it?
I think toll-free telephone numbers are about 30, 40 years old now.
Yeah, it's like, I was a bit too young to understand that period. But it was basically by fiat. AT&T came along and said, we are the long-distance company and we're going to do it, and we're the only one. So hey, it's Marbell says, and the thing is that the new Marbell is called Apple, and and if anyone can say this is how it's going to work, they're the ones who can do it, because they might only have 20% of the smartphone market, but their customers, if you think of it, the 1%, their customers are the 20%. Yeah, it's most of the
and the new Marbell might be Facebook.
Could be. Facebook has screwed up to me a bit, which is they have built a model around the business process of advertising or marketing services. But every business in the world has this set of things they want to do with customers. They want to identify and authenticate customers. They want to market to them, which include advertising, but also customer surveys and research and a whole bunch of other marketing services. They want to do e-commerce, so sell stuff. Order fulfillment, online and offline, billing and payment, customer service. All of those require interaction with customers. And FreePhone is one way in which all these things are done today. But Facebook have failed to build a suite of services that serve the needs of enterprises to interact with their customers across that whole life cycle. And Google have failed too largely as well, and Twitter have got little bits of it. So they got some potential for doing an interesting way of interacting with customers, but still, nobody's really grabbed hold of it. So far, telco operators have been lucky in that, nobody's turned up with a bullet in the gun. It's always been blanks.
Yeah, I completely agree. I think, Wednesday, February 29th, 2012, right now it's a wide open playing field. It's a free-for-all.
Yep.
But all I'm saying is, what has happened this week and, with recent Skype announcements and so forth, there's clearly an awakening that's happening, in my view, that, whatever the window is, somebody's going to step in and, control that window.
The AT&T announcement definitely legitimizes the space.
Exactly. But, the positive thing is, in the public's mind, in my view, there is still a brand and a trust and a, very deeply ingrained use case for the 1-800 model. So people trust dialing a 1-800 number. They're not thinking about malware. They're not thinking about what's this going to cost. There's still a kernel of value and trust and assurance around, the toll-free telephone number model.
It's packaged.
Yeah, it's a package, and but it's so hampered by functionality at this point. People, there's still a set of use cases where people want to talk to somebody during a transaction, but there's a growing set of use cases where I don't want to talk to anybody.
No,
I want to,
simple stuff. I want the IVR pushed down to me so I can navigate through the IVR on my smartphone. There's companies like Fonolo who do that, and so the whole interaction model of is going to be disrupted by the smartphone.
Yes. Yeah, and I don't think if you had told people 2 years ago, hey, 50% of the people are going to have a smartphone, not just in North America, but globally.
Yeah.
Most people would say you're crazy, but in fact, that's where we're headed, and the vector is getting stronger, not weaker.
Yeah.
So
good. The hour is nearly up. So I want to encourage anyone who wants to keep following the stuff I write. Then sign up for the newsletter that comes out every month. www.futureofcomms.com, and I really look forward to future conversations.
Yeah. Any final questions anybody has? I'm sorry we kind of burn up the hour, but.
I'm sorry, what was that website, Future of Comms?
Comms. So www.futureofcomms, COMMS, as in communications.
Okay.
Yeah, or Google for Martin Geddes, and you'll find me in it very quickly.
Okay.
There should be links. There should be links on the Phoneword forum page, as well as the invitations that went out to you. I would like to say that Martin and his partner Dean Bubley, who's also a noted visionary in the whole world of telecommunications, media, etc., hold the Future of Voice sessions.
Yes. So around the world. We're going to be running some more. Last year we ran a number of Future of Voice workshops, small workshops, 20 people, about the whole future of the voice industry, and covering some of the stuff around we're talking on this call. So there's going to be some more coming up, 2 in London, so a Future of Voice and Telco OTT services in London, and then in Washington, D.C., so London end of April, Washington, D.C. middle of May, If you go to futureofcomms.com, there's a little bit more information, but we'll be launching them, the next lot, soon. Sign up for the newsletter, and you'll get details. And if you want to follow me on Twitter, then Martin Geddes is my Geddes is my Twitter handle.
And also, Martin expressed to me, and I'd like to throw this out to everybody, he's interested in speaking on Sender-Pays data or attending conferences where this topic will be discussed. So, my recommendation is anybody that's putting on a conference and they're interested in having somebody speak on Sender-Pays data, Martin, in my view, is the resource. So if anybody on the call or listening to the call later on hears of an opportunity, please contact me or Martin directly. So
great. Thank you all.
All right, we're at the top of the hour. I appreciate everybody's time and attention. And next month we're going to have Aaliyah Christofferson of ATL Communications talking about updates in the North American toll-free industry and governance, and some initiatives that are underway to usher in a open market or market-based allocation method for toll-free telephone numbers. So that will be the final Wednesday of March, same time, 4 p.m. Eastern, and appreciate everybody dialing in.
Good. Thank you.
Right. Thanks,
Good evening.
Thank you, Martin. Bye.
Thanks. Bye.
Yeah.